Now our goal is to eliminate factors of the form a minus bx squared. And to do this, we'll do another sort of trig substitution. We'll let a minus bx squared, and what we'll do is we'll replace the bx squared with a sine squared of theta. And when doing this, notice that if we factor out the a, 1 minus sine squared is the same thing as cosine squared. Now if we go this route, notice that we're having bx squared equal a sine squared. So our x squared should be a over b sine squared of theta, and our x should be the square root a over b sine of theta. And as usual, that's what we're letting x equal, and everything else follows from that fact. Now, how do we get all values of x from this? Well, we can't. Remember that sine is between -1 and +1. So let's make a note here that if that's the case, then x has to be between root a over b times 1 and no bigger than root a over b times -1. Put more simply, the absolute value of x has to be less than or equal to root a over b. And this is just a technical requirement. Fortunately, if you have in your original problem a square root, as we often will do, then just because this is exactly the domain of x values which don't cause a negative underneath the square root. So this will not be a huge problem. So we don't have to worry too much about that. But we also should make a note that in this process that we don't want repeated x values for different theta values. So we're going to let our theta range between pi over 2 and be as small as -pi over 2. And if we have that be our theta values, then the sine function would look something like this. This is the top of the sine curve and the bottom of the sine curve, and that's the positive root a over b, and that's negative root a over b. And so we get all the x values between negative root a over b to positive root a over b for these theta values between -pi over 2 to positive pi over 2. Let's see this in action. For example, let's find the integral of 4 minus 25 s squared to the -3/2 power with respect to s. Now, if there was another s sticking outside right there, then this problem would be easy. We could do a direct substitution, let u equal 4 minus 25s squared, and we'd be good to go. But unfortunately, we don't have that. We're going to have to use this trig substitution trick. So let's do that. Let's let, what do we have? 4 minus 25s squared. And you always keep the constant by itself the same because you can't change the value of the constant. But we can involve the term s. We can rewrite that with a different variable. And we'll rewrite that with 4 sine squared of theta. And that would get us the same thing as 4 cosine squared of theta. So that meant that our 25s squared was 4 sine squared of theta. And then s squared is 4 25ths sine squared of theta. S is 2/5 sine of theta. When we take the square root of both sides, that is the actual substitution that we're involving in this problem. So where do we go to from here? Well, we need to know what ds is. So let's compute that, take the derivative. Sine becomes cosine. And now we can substitute back into the original problem. And we just saw that 4 minus 25s squared is 4 cosine squared. So I'll make that change. 4 cosine squared of theta, and then to the negative 3/2 power, then the ds becomes 2/5 cosine of theta d theta. Where to from here? Well, let's rewrite this a little bit simpler. We've got 1 over the cube of the square root 4 cosine squared of theta, 2/5 cosine of theta d theta. And I like writing out the fractional power like that because it makes it a little bit easier for me to see how to proceed. In fact, what do we get? The square root of 4 cosine squared. That would get 2 absolute value of cosine of theta, all of that cubed, times 2/5 cosine of theta d theta. What can we do? Well, we can cancel the 2 on the top and bottom. No, we can't, right, because of that cube here. So let's be a little more careful. And let's expand out that cube. One over 8 absolute value cosine of theta. That still needs to be cubed. 2/5 cosine of theta d theta. Now I can cancel the 2 with one of the 2's down here, leaving a 4. But we really need to take care of this absolute value. And that's where I note that, well, maybe I was overthinking it a little bit. We made a promise way back when that my theta value was going to be between negative pi over 2 and positive pi over 2. And notice that on the unit circle, these are the values between negative pi over 2, positive pi over 2. And the cosine of theta is the x value here, and that's positive along this portion of the unit circle. So, way back down here, that absolute value, I can scratch that out. That means that one of the cosines on the bottom can cancel with the top. So let's simplify everything. I got the 2 on the top is canceled. I've got a 4 times a 5 on the bottom. I'll just bring that all the way out, 1/20th. And I have the cosine is canceled. I've got 2 cosines in the denominator. That's the same thing as, well, let's write it out, cosine squared of theta d theta, which looks hard until you remember that that is just the integral of secant squared of theta. We're almost done. Integral of secant is just tangent. So we got 1 over 20 tangent of theta plus c. But then we have to remember, tangent of theta, theta is something that I made up. I made up that tangent way up here. The theta was made up right here. S is equal to 2/5 sine of theta. That's my theta. I need to get back in terms of the S. All right, well, I know what sine of theta is, all right, because I can solve that. That's going to be sine of theta is 5 over 2S. So that's easy enough. But what am I going to do about cosine? Well, fortunately, I have that ready as well. Up here, I saw that I wrote 4 cosine squared is equal to 4 minus 25s squared. So I can take that and write that as 4 cosine squared is 4 minus 25s squared. We can divide by the 4 on both sides to get rid of it on the left. And then to get rid of that square, I'll just take the square root. Remember that for our theta values, the square root is positive. Cosine is positive, so the square root will be positive here. So there's my cosine. And you can simplify that a little bit if you like. You can write that as square root 1 minus 25 over 4s squared. Distribute that 4 into both terms. So there's my cosine and my sine. Well, I asked for tangent. Well, that's just sine divided by cosine, right? So way back down here, I have 1 over 20. Sine, we saw, was 5/2 s. Cosine, we saw, had a square root, 1 minus 25/4 s squared. Finally, let's do a little bit of simplification here. We can take that 20 down here. We have a 5/2 on the top, so we can write that. We can cancel a 5 here and here to get a 4, and then that would get us 1 over 8. So I can just write this as s over 8 root 1 minus 25 over 4 s squared plus c. And you can bring that 8 into the square root if you want to cancel the fraction on the inside, but that's probably simplified enough for our purposes. And there is our final answer.